Hey everyone, welcome to More Stats, and today we're going to be doing day 1 of 6.2, which has to do with discrete probability distributions and some actual calculations. So let's hit it over here on the next screen. We've got, suppose you get a new job and every day your boss, that's me, draws a piece of paper, a slip of paper out of a bag to determine your wage for the day. Let the random variable x be equal to the daily wage in dollars per hour. So you're going to get a different wage every day depending on what paper you draw out of the paper bag. Now, we did this in class a couple of years ago, and last year, of course. And this is one of the probability distributions we came up with for that. So one person got a wage of $5. And then when we added all of the class data together, we got this probability distribution. So 12 out of the 29 students got a dollar wage. 8 of this 29 students got a $5 wage. 5 of the 29 students got a $7 wage, and right on down the line until we got one lucky student got the $25 wage. Lucky kid. As a little bit of a review, we're going to calculate the expected value of x. So the expected value is the same thing as the mean. You're just going to multiply and add right on down the line, and you get 5.069. That was a little bit of a review from what we did on 6.1 day 2, I think it was. So if we calculated wages for many, many days in this way, the average wage would be $5.69 a day. So next is, recall that in chapter 1, the standard deviation tells us the typical distance from the mean. So we're going to complete the table here to figure out the standard deviation, or the typical distance from the mean. The first thing we need to figure out is the distance from the mean. So we're going to take all of these wage values, say this 1, and we're going to subtract from that 5.069. There we go. 5 minus 5.069 is negative 0.69. 7 minus 5.069 is 1.931. And down to 15 minus 5.069 is 9.931, etc., etc. Next, we're going to take all of those deviations. When you subtract the mean from all of the observations, you create a deviation. So now we're going to square all of those deviations. So we got negative 4 squared is about 16. Negative 4.069 squared is about 16. Negative 0.069 squared, that's about 0.005. 1.931 squared is about 3.729. All the way down the line, notice that all of the squares end up being positive, which is the desired result here. Next, we're going to figure out the weighted distance from the mean. And what that means is you're going to take each of these squared distances and we're going to multiply by the probability. So the probability of getting a wage of $1 was, what was that, 12 out of 29. So we're going to take 12 out of 29 and multiply that by 16.557, and we're going to get 6.851. Same thing down here with 15. The probability of getting a wage of $15 was 1 out of 29. And if we multiply the squared deviation by a 1 out of 29, we get 3.041. All the way down to 25, the deviation is 19.231. Square of that deviation is 397. And then if we multiply that by the probability of getting a wage of 25, which was 1 out of 29, we get 13. So those probabilities kind of bring these numbers back down to scale, if you will. And now, that process was called this process is called finding a weighted average, because we're weighting all of these outcomes by the probability. Or that's what we did for the mean anyways. Still some kind of a weighting going on here. We're going to add all of those weighted deviations together. That gets us 26.271. Like always, that number is not a typical anything, so we're going to take a square root of that using that kind of a Pythagorean formulation here to get our actual standard deviation. So like you might expect, the square root of a number near 25, like 26, is a number that's close to 5, like 5.126. So that is our standard deviation. The standard deviation of a discrete probability distribution. That's a whole lot of functions that you need to do in order to get that. We're going to show you the quick way to do this on your calculator in a few moments. But now we're going to interpret that standard deviation. A wage typically varies from the mean of 5.069 by about $5.13. So I promised you that I would show you how to do this the quick way on your calculator. So let's take out our TI-84s and see how to do this. So take your calculator, push Stat, and then Edit. And then you're going to put your data into L1 and L2. It's hard to see, but I really did put this one was 12 out of 29, or 12 divided by 29. So take all of that, go back to the home screen, and now we go Stat, Calculate, and One Variable Statistics. Now in One Variable Statistics, this is where we're going to use the frequency list. List 1 is going to be the numerical outcomes. List 2 will be the probabilities, which is the frequency list. And then we push Calculate. And that will come up with our same mean, 5.069, and our same standard deviation, 5.125. So that's a really quick way with a probability distribution, a discrete probability distribution, to find that mean and the standard deviation, which I know that this information is going to be useful to you when you got to do this on the AP test. Back to our work here. And Ferreria decides that she would rather assign wages so that each employee could get any amount between $10 and $20 and all are equally likely. So draw a graph to represent this probability distribution. And the key here is all are equally likely. So that means that we're not just looking at wages of $10, $11, $12, $15. We're also looking at wages of $10.21 or $10.996 or $15.189624. This is a continuous probability distribution. And in a continuous probability distribution, we can't make a table of all the values, so we have to draw the curve of what those probabilities will look like. So we're going to draw basically a rectangle here. The important part is this bar right up here, the height. All of the probabilities between 10 and 20, or all of the outcomes between 10 and 20, have the same probability, which is why you see this horizontal line here for probability. Now, we got to figure out how tall is that bar, and in order to figure out how tall that bar is, we're going to use the property that all of the probability in there has to equal 1. And if all of the probability there has the same height, then it looks like a rectangle. So the area of that rectangle has to be 1. Geometrically speaking, the base times the height has to equal 1. And the base of this rectangle is a width of 10 units. So the 10 times the height is equal to 1, which means that the height should be 1/10. Now that we have the height is 1/10, if we want to find any probability, we just need to locate the correct region and find the area of that region. So for number 6, when it says what's the probability that an employee makes between 12 and 1250, we end up looking at this green rectangle right over here between 12 and 1250. Well, what is the area of that green rectangle? area of a rectangle is base times the height. And if we're going from 12 to 1250, that means the base is 0.5. And we already found out that the height was 1/10. So 0.5 multiplied by 1/10 is 0.05. So in probability notation, we would say the probability that a wage is between 12 and 1250 is 0.05, and that the probability an employee makes between $12 and $12.50 is 0.05. Brings us to our important items. So the standard deviation, we already saw how to compute that using the formula. We saw how to compute that using a calculator. We didn't talk about variance, but variance is just the standard deviation before you took the square root. So if you want to find variance, you're just going to square the standard deviation. Learning target 2 is how do we deal with continuous random variables? Well, first of all, we find the area under the curve. If we have a uniform distribution, remember that if the base is x units long, the height is 1 over x. And then for normal distributions, we're going to use all the normal stuff that we learned in, I think it was chapter 4 or chapter 3. Either way, we're using normal CDF or table A. If you're in my class, I'm telling you to use normal CDF. So now let's check our understanding. The heights of young women can be modeled by a normal distribution with a mean mu equals 64 and standard deviation sigma equals 2.7. Suppose we chose a young woman at random. Let y be her height in inches. So notice that we said this is a normal distribution, so that's a cue to you that you should be using normal CDF for a lot of these calculations. So what type of variable is y? Is it discrete or is it continuous? The height can take any value in its range with no gaps. So this is a continuous distribution. Next, interpret the standard deviation. And this is another one of those standard set phrases. A young woman's height typically varies from the mean of 64 inches by about 2.7 inches. Next, let's find the probability that a young woman's height is less than or equal to 63 inches. First, we know that we're dealing with a normal curve, so we're going to draw our standard normal curve. I have this set graphic where I have all the standard deviations on top and all of the z-scores above that normal curve. Next, you're going to go ahead and find the mean, the standard deviation, and you're going to label and shade the places that's important to this problem. For us, that means that we're looking at less than 63. If we look, 63 is right here to the left of the mean of 64. So we're looking at a probability of less than 50%, maybe around 40%. After we've shaded our normal curve, we're going to go ahead and put our equations together. In this type, we know the z-score is going to be 63 minus 64 over 2.7, which is negative 1.370. And then next, we're going to find out that probability using our calculator, and we get 0.3556. Just to refresh your memory, the correct calculator notation is normal CDF with the low is equal to 0, the high is equal to 63, the mean is 64, and the standard deviation is 2.7. So wonderful. This is actually a pretty easy problem. This is the bread and butter of statistics right here. Hopefully you all got that. Moving on. Find the probability that a young woman's height is between 68 and 70. And interpret this value. So starting with our normal curve, we're going to go ahead and identify our region, and we're also going to add some of the standard deviations and the means along the way. So here's our normal curve. I've added the standard deviations in green, 64, 66, 7, 69, 4, and 72, 1. And those are only to help us place where 68 and 70 are in this curve. So we know 68 is a little bit to the left of 69, and we know 70 is a little bit to the right of 70. And I've shaded that area in, this time in red, just to contrast a little bit. Now, we have two z-scores to deal with, so I'm going to call them z1 and z2. Next part of this is to put in our two equations. The first of those equations are the z-scores. These are pretty easy to compute. Notice that I get a 1.41 or 48 and a 2.22. After we get our z-scores, we do our probability. So we have the probability of a z-score between 1.481 and 2.222 is 0.0561. Remember to keep anything that comes out of normal CDF to 4 decimal places. Now, if you don't remember again, how did we get that number? We've got normal CDF, low is 68, high is 70, mean is 64, standard deviation is 2.7. So hopefully that was a lot of good remembering for you here on our AP Stats, and we'll see you next time. Have a good one.